All right. Well, welcome back, folks. And let's go ahead. Let's pick up with where we left off with yesterday. Try to finish up with this chapter. Limiting reagents, like we learned yesterday and on Monday, are just the reactants. Okay, limiting reagents, first of all, refers to only the reactants. Okay? So we're only looking at the starting material. And what we're doing when we define and describe and we're trying to identify the limiting reagent, we're just trying to find which one of those reactants runs out first. And so in our hot dog example, we saw that in making a hot dog, sometimes it's the bun, sometimes it's the hot dog. It just depends on which one of those react, how much of which one, each reactant we have. And based upon that, we can go ahead then and do a stoichiometric calculation to find that out which one runs out first. Okay? And so the limiting reactant is the reactant then that runs out first. And because of that, it limits how much product we get. And that's why we refer to it as a limiting reactant. So finding the limiting reactant then just involves us doing one stoichiometric calculation. Okay. And so remember, we did two yesterday, but I told you yesterday, you choose one or the other reactant to as your starting amount, okay, as your starting quantity. You don't have to do both calculations unless you want to. But once you have your calculation done, you take the calculated amount, you compare it to the amount that you were given to start out with in the problem, and then you do your comparison. Getting the number, getting the calculated amount, I hope should not be too difficult at this point. You should continue to practice these calculations, but make sure then that if you are having issues with doing the calculation, doing the stoichiometric calculation, this mass to mass conversion or volume to volume conversion, which we'll do also, if you're having trouble doing that, folks, you got to practice that because you need to know how to do that before you can do the limiting reagent calculation, which is just a stoichiometric calculation. Because what you have to do is after you've done the calculation, you have to be able to interpret that number. And so that's why if you're not quite sure how to do the calculation or if you still need more practice with it, if you're uncertain how to do it, you got to do it and then come by and see me and get some extra help with it. Because now what we're doing with the limiting reagent is we're taking that, what we know about how to do that calculation, and we're applying it then to determining which reactant runs out first. We're applying it to answer the question, what is the limiting reagent? Okay. All right. So with that said, then you've noticed from the problem we did yesterday, okay, and also from our hot dog example, that the amount that's present, the given amount, okay, that is the smallest given amount, isn't always going to run out first. And so make sure you take out the problem that we did yesterday to take a look at that. Okay, you saw that yesterday we were given 80 grams of copper, okay, and 25 grams of sulfur. 80 grams of copper, folks. 80 grams is a whole lot more than 25 grams. But we saw then yesterday then, and let's go ahead and write this down then. Okay, we saw then that yesterday the 80 grams of copper. Okay, so yesterday's problem, okay, we were given 80 grams of copper, okay, and we were told then that we had 25 grams of sulfur. Okay, so given these amounts there, it looks like we have a whole lot more copper than sulfur. Okay, but the reaction that we had yesterday was the reaction, but within the context of the reaction, which was the reaction forming copper 2 sulfide. Okay, we saw then that the limiting reagent actually was copper. Copper was the limiting reagent, even though we have a whole lot more copper here. Okay, 80 grams is a whole lot bigger than 25 grams. But what we're saying here is that copper is getting used up a whole lot faster than sulfur. And we can kind of see that in our balanced equation here. This is a 2-to-1 mole ratio, which means then for every 2 moles of copper that is being used, we only need 1 mole of sulfur. So the amount, the rate at which we're using copper in this reaction here is twice as fast as that of sulfur. Now, that 2-to-1 does not correlate directly to the mass here, but what we can do is we can see then that if copper is being used up a whole lot faster, okay, we can imagine then that more of it's going to be needed. So here, we saw yesterday then that we needed a lot more copper to use up this 25 grams of sulfur. And so because of that, copper then was our limiting reagent. Okay, so make sure you keep this in mind. Just because you have an amount here that is bigger does not mean that this is excess. And just because you have an amount that's given to you that is smaller does not mean that it is the limiting reagent. Okay, so remember yesterday, based upon the amounts here, we saw that copper was the limiting reagent and sulfur was our excess. Okay, so make sure you keep that in mind as you go forward. You have to do the calculation. You cannot just assume which one. Assume the smaller, the reactant that is present that is smaller. Okay, necessarily runs out first. Okay, so that's not going to be the case. So that's why I want to make sure I highlight this in red for you. Okay, and make sure you see that. Okay, all right. So like I told you yesterday, folks, we're going to practice this and we're going to do a lot more of these problems here, a few more. And then tomorrow, if we have some time, I'd like to do a couple problems from the homework that's due tonight. So please make sure you get that homework done. Okay. And then we'll work it out. Okay. All right. Let's work this problem out together. Okay. So what I'd like to do is take about 5 minutes, work out this problem here. This is number 19 in your problem set. Okay. And then what we'll do is we'll work it out together. Okay, so take about 5 minutes, work it out on your paper, okay, and then make sure then you write down the work that we're going to do right now, okay, and then submit it at the end of the period. But I'd like you to practice this, okay, and then we'll work it out together. So go ahead and work out this problem. Okay, let's work out this problem here, folks. Okay, and whoops, sorry, let me go ahead and backtrack here. Okay, let's go ahead and let's, like I told you, first thing you should always do is write down what you're given. Okay, so here you are given the balanced equation already. You're not asked to find the balanced write down the balanced equation. They actually give it to you. So I would always suggest that you check it anyway. Check to make sure that everything's balanced. Okay, and so here, just a quick check here: 3 hydrogens, 6 hydrogens on both sides, 6 hydrogens here. 1 phosphate on the left-hand side, 1 phosphate on the right-hand side, 3 sodiums on the left, 3 sodiums on the right. Okay. Then we have 3 oxygens here, 3 oxygens here. We're good to go. Okay. All right. So with that said, next step is write down what you're given, the given quantities. Okay. So we are told then that we have 1.75 moles of phosphoric acid. Let's go and write that down. So that's what we're given. We have 1.75. If you notice here, the unit now is moles, not mass, not volume. Okay. But that's okay. We can still go ahead and work this problem out. Okay. All right. So with that said, then we are also told that we have 5 moles of sodium hydroxide here. So let's go ahead and write that down. So we have 5 moles of sodium hydroxide. And they're asking us to identify, that is, they're asking us to find the limiting reagent. Okay. So here, if we notice this, we're given 1.75 moles of this reactant and 5.0 moles of this reactant. It appears here, so this is the given amount. Okay, so this is given. Okay. It appears then that we are given less H3PO4, less phosphoric acid than we have sodium hydroxide. Okay, so does that mean then that we run out of phosphoric H3PO4 first, and this must be our limiting reagent? It could. However, like I told you on the previous slide, that's not always going to be the case. So we still have to work out this problem. We still have to do the stoichiometry. Okay? All right, so that is, we still have to do the conversion. So with our conversion here then, okay, we can do 1 of 2 conversions. And again, I'll do both for you since this is kind of a simple one. Okay? The conversion then just involves you picking one of the given quantities here to start out with and solving for the other one. Okay, and so that, let's just go ahead and start with phosphoric acid here. Then, okay, let's assume that we have 1.75 moles of H3PO4. Okay, and so the conversion here then is we're going to try to find then the equivalent moles of NaOH. Okay, so this is going to be a mole to mole conversion. Okay, if this is a mole to mole conversion, the only conversion factor that we need is the mole ratio. And where do we get that mole ratio from? Well, the mole ratio is taken directly from the balanced equation. So we have a 1 to 3 mole ratio here. So let's go ahead and plug that in. So this problem ends up being very simple, folks. Okay, so let's go ahead and plug this in then as 3 moles of NaOH over 1 mole of H3PO4. So plugging that in then, let's go ahead and get that real quickly. 5.25 moles of NaOH. So this is the calculated amount. So this is going, let's write this down. This is the calculated amount. Okay, that's calculated. Okay. And so remember what we did then, once we have that, let's compare this calculated amount of NaOH to the given amount of NaOH here. So let's go ahead and do that. So the calculated amount of NaOH, let's go and write that down here, is 5.25 moles of NaOH. And let's compare that to the given. What's given here is right here. And again, we're comparing, this is NaOH, so we got to compare it to the given amount of NaOH. We're not going to compare it to this one. We're going to compare it to this amount here, which is 5.00 moles of NaOH. So the calculated amount is greater than the given amount, okay, which means then NaOH will be our limiting reagent, because we need more than what we were actually given. So NaOH here, okay, so even though we are given more of this, NaOH is our limiting reagent. And we obtain that from the balance equation. So NaOH, the 5 moles of NaOH is our limiting reagent. It will run out first. And again, how do we know? Because to use up all of this H3PO4, we need this much NaOH. Well, we're only given in the problem this much here. Okay, so we have less than what we actually need. Okay, so the calculated amount, remember, is the amount that's needed. This is the amount that's needed to run the reaction and have nothing left over, but we only have 5 moles. Okay, we are short. We are short 0.25 moles of NaOH. Okay, all right. So with that said, then. Hopefully you were able to get that done. Okay, but let's say then, so make sure you write this down. Okay, make sure you write this down, because I want to go ahead then and let's say then you didn't do this reaction. Let's say you didn't do this calculation, but you had chosen to do this one. Okay, so let's go ahead and let me erase this really quickly. Okay, and let's do the second reaction. Okay, let's do the second calculation. Okay, and let's see, and let's interpret that answer. Okay, so let's go, let me erase this here really quickly. All right, let's say then instead of doing the calculation using 1.75 moles of phosphoric H3PO4, which we just did, you chose to start out with the 5 moles of NaOH, and you wanted to calculate for this. So this is the second possible calculation you could do. Okay? And so you're going to find then the equivalent amount of H3PO4 in moles. Okay, so again, a mole to mole conversion. So we need the mole ratio here. The mole ratio is going to be 1 to 3 mole ratio. 1 to 3 mole ratio this time. 1/3. Hopefully you see why, because you want to cancel out moles of NaOH. So this will be 3 moles of NaOH. Okay. All right, you plug that in, you have then your answer then will be 1.67 moles of H3O4. So this is our calculated amount. So that's the amount we calculated for, okay? Which then again means, what this means then is this is the amount that's needed. Okay? This is the amount of H3PO4 that's needed, a phosphoric acid is needed. So let's compare our calculated amount. Okay, so we calculated for this that we need 1.67 moles of H3PO4. Our given amount, that is what we start out with. So remember, the given is always going to be what we start out with, is 1.75 moles of H3PO4. And so if you notice here, this time the given amount is greater than the calculated amount, which means then we need 1.67, but we have what we were given to start out with is 1.75. So we have more than what we actually need, which makes then H3PO4, this amount here of H3PO4, that will be our excess. Okay, so if you had chosen to do this calculation, you would have found out that H3PO4 is the excess, but the question is asking you about the limiting reagent. And so at this point, then you don't have to do the second calculation. You can just, by deduction, if one of the reactants is in excess, if there's only one other reactant, that must be the limit. So however you choose to do this calculation, it's completely up to you, but you got to make sure then that you do this work right here. Now, the analysis here, you don't have to write this out. If you want to write it out, go ahead and do so. Okay, but this part here, the part that I've highlighted in green, hopefully you're doing that in your head. So if you are able to do that that analysis in your head, then great. If not, then go ahead and write that down. Okay, so make sure you you do that. Okay, and again, you don't have to do both calculations. You just have to do one of them. Okay, and then and then interpret the answer. Okay, so with that said, okay. There are steps that you can take, and I'm going to give you the steps here, folks. And I just want to point out to you that, again, these steps here are for you to help you, but don't memorize them. Okay. So what you want to do then is have these steps in front of you, but by practicing and just going through in your mind what you have to do. And by practicing it, you'll have these steps memorized. Okay, so just by doing rather than trying to memorize. Okay, so you always start with the balance equation, and you want to determine the limiting reagent. You do so. I'm sorry. Oh, let me go ahead and backtrack here. I want to work out one problem with you really fast. Okay, let's go ahead, and I'd like you to do before we do this. Okay, before we go on to this one. Okay. Sorry, let's do number 12 in your problem set. Okay, so let's go ahead, and I would like you to do number 12 in your problem set. Okay, and then we'll go over together. So I'm sorry, before we go on to this one, let's practice one more. I did promise you that we'd practice limiting reagent problems. Okay, so let's do number 12 in your problem set. Okay, and so get your problem set out. Go ahead, and let's take about 5 minutes to do number 12 in your problem set, and then I want to go over it with you. And then we'll talk about how we can find the amount of product that we need. So we'll go on to this topic in just a moment. Okay, so good. Do number 12 in your problem set. All right. So number 12 in your problem set, they describe a reaction, okay, between magnesium and HCl, hydrochloric acid. Okay, and so let me go ahead then, and you may not know what hydrochloric acid is, so if you didn't get it, that's fine. Okay, but let's go ahead. Hopefully you're able to find it online, okay, as you work through this. But let me go ahead and write this out for you. So always start out. So again, we're doing, and let me go ahead and highlight this here. We're doing number 12. From your problem set. Okay, so let's do number 12 from your problem set. Okay, so we're starting out then with magnesium. Okay, and we're going to react it with HCl. That's hydrochloric acid. Okay, and with that said, then we will produce magnesium chloride, which is MgCl2, okay, as an aqueous solution, and hydrogen gas. Okay. So that's the equation. Let's go ahead and balance it. So it's going to be a 1, 2, 1, 1 balance equation. Okay, so 1, 2, 1, 1 will balance out the equation here. Okay, all right, so let's go ahead and write down what we're given. Let's go ahead and write down what we're given here. So we were told then that if we start out with 5, we're going to start out with 5 grams of magnesium and 6 grams of HCl. Okay, all right, so the two possible calculations that we can do. And so we got to find the limiting reagent first. So the question then is, what is the limiting reagent? Okay, so what is the limiting reagent? So if this is what we're given, okay, so we're given these two quantities here, okay, what is the limiting reagent, and how could we solve for it? Okay, and then what we'll do then, we'll continue using this problem here, but what is the limiting reagent if we're given these two amounts here? Okay, all right, so let's go ahead and I will do it one more time for you. I will solve it for both ways, okay, but again, make sure I'll do both conversions for you, but make sure then that you, as we move forward, you only need to do one of them, okay? All right, so the first conversion. the first one that we can do is starting out with 5 grams. Sorry, 5 grams. Let me get that in. Okay, starting with 5 grams of magnesium. So make sure you understand this amount here, I took straight from the given amount here, but this time we're going to solve for the grams of HCl. And it's not going to be this, not necessarily. Sometimes it will. On your homework, you'll see that, but we still have to check. Okay, so what we're doing is we're solving for the amount of HCl here. This is the amount that's needed to use up 5 grams of magnesium, and it may not be this number, so don't assume that. Okay, so let's go ahead and let's do the calculation. Okay, so this is a mass to mass conversion. So that means that our first conversion factor, molar mass of magnesium, which is going to be 1 mole of magnesium, and 24 grams of magnesium, straight from the periodic table. Okay, second conversion factor, mole ratio between HCl and Mg. That's going to be a 2 moles of HCl over 1 mole of magnesium. Okay, and then finally the molar mass of HCl here, which is going to be 36. We'll plug that in as 36 grams of HCl over 1 mole of HCl. All right, so we plug that in. So all the units will cancel out. We plug it in. We end up with an answer here that is 15 grams of HCl. Okay, so let's go ahead and let's understand this. This is our calculated amount here. This is the calculated amount of HCl. And so what do we need to do now? We need to compare this calculated amount to the amount that's given right here. So let's go ahead and do this. So the calculated amount, okay, the calculated amount is 15.0 grams of HCl. The given amount of HCl is right here, which is 6 grams of HCl. Which number is bigger? The calculated number is bigger. Okay, so now that we've determined that the calculated amount is bigger, remember, you got to make sure you understand what that means. This means then that this is how much we need. This is the needed. This is how much we need. We need that many grams of HCl. We were only given this amount of HCl, which means then we have less than what we need. We have less HCl than what we need, which means this runs out first. HCl then is our limiting reagent. Okay, so HCl is our limiting reagent based upon this calculation here and based upon comparison of those numbers there. Okay. All right, so I'm out of time here, folks. So what I would like you to do for tomorrow, okay, if you did if you did both, you're fine. You don't have to do any more, okay? But I did I did this calculation for you. If you what I want you to do then is if you did this one correctly, okay, I want you to do the other one, which is if you had started out with 6 grams of HCl, how many grams of magnesium will you need? So I want you to do this calculation here, okay, if you did this one already. So, or if you did this calculation already, the one I'm asking you to do now, then you do the one I just did for you. Okay, so you just have to copy that down. Okay. All right, so what I'd like you to do on your paper then is, on your paper when you turn it in, you should have 2 calculations for this problem here. Okay, so go ahead, write out the second of the 2, okay, submit that, and then what we'll do is we'll finish up this problem tomorrow, and then we're going to go on and we're going to talk about how we can determine then the amount of product that we can produce once we know what the limiting reagent is. And I kind of already previewed that for you, so we'll go ahead and get that done tomorrow. Okay. All right, folks, have a good day. If you have any questions, come on by and get your questions answered. I'm hoping that we can try to finish up by Friday, which means that, so obviously we won't have the exam this week. Okay. We'll finish up by Friday. Let's see how far we get, and then the exam will be pushed till next week. Okay. All right, have a good day, and I will see you tomorrow.